maybe I can just call this practice in Lagrange interpolation. You may or may not need it. Sorry. It's true. You have to get better at these things. And soon we'll be dealing with Olympiad questions. Okay, polynomials. Because here also we have covered some things already. Right. Let me begin with a simple, very simple question. Here we have a P. So P is a polynomial. Just say that degree of P is less than 4. And these values are given. P of 2 is 4. So this is just straight from the straight problem. Okay, it's straight. P of 4 is 5. Okay. Find. So you could also just tell me the answer. Just, I suppose honestly you do it and then tell me. So as usual, you'll notice that I am not saying that the degree is 3. The degree could be 3. It could also end up being 2. It could end up being 1. And we cannot do anything about it. But it's not more than 3 is an important, it's not more than 3, yeah, is important. So we know that we don't have 2 polynomials, right? There will be at only 1 polynomial satisfying these conditions. That we have proved, right? Degree is this much, and so this many equations are given. You cannot have more than 1 solution. Very good. Now we just calculate and tell the answer. There are not many problems on this topic in Brilliant. So is it
X minus 2
uh,
the first.
just right, just this got moved. What is it? Okay. Sorry. Yeah, so what is it? X minus 12. Okay.
X minus 2.
Sorry. X minus 2. Okay.
X minus 3.
Right.
X minus 4.
Right.
What? Minus 1, minus 2, and minus 3.
In the denominator?
Or 1 minus, yes. 1 minus 2.
1 minus 2, right. Because when you put 1, then this will become 1, numerator will become 1 minus 2. So you want to cancel that and so. Right. Okay. So maybe, so let's see. I want someone else to now tell the second term.
Sir, the second one will be x minus 4 times x minus 1 into x minus 3 into x minus 4. By 2 minus 1 into 2 minus 3 into 2 minus 4.
Okay, so now that's okay. So now, Pragadish, you tell me the third term, one more term. Just because I want all of you to be able to easily compute this. That is important.
So it will be 3 times
3. Oh Lord. So how do you get the 3? Is 3. So well, notice that just from the pattern.
wait, no, okay.
Right.
So will it be 1?
Okay. 1.
I don't fully understand this.
Right. But you can see like just the pattern, just from the pattern, right? When you,
Yeah.
for 1, we did not have x minus 1 here. Right?
Yeah.
So that's it. And so for here, we won't have x minus 3. We will have x minus 1. I mean, that's, yeah, this is basically a formula. Then you then just remember for the time being, right? And I used to just remember it for a long time before understanding. So yeah, x minus 1 times x minus 2 times x minus 4, right? This is just matching with the other two. And this thing 1 is just the value of the polynomial at 3. Just like this is the value of the polynomial at 2, right? P of 2. That's it. And the denominator, you can see what we are dividing by is also a very clear thing. Right? It is 1 minus 2, 1 minus 3, 1 minus 4. This is 2 minus 1, 2 minus 3, 2 minus 4. So this will be what? 3 minus 1, right?
Okay, but why is
Yes.
so in the previous term it was x minus 3 in the middle, and now why is it x minus 2?
Yeah, so the fact that it's in the middle is not very important. The point is that
No, I just wanted
right,
to.
yeah. So the only factor that is missing in this is x minus 2. Right?
Okay.
And the only factor missing in this is x minus 1. And the only factor missing in this should be x minus 3.
X minus 3.
Right? And the rest you can write in any order. That doesn't matter. You can write x
Okay.
minus, yeah. So we just write from left to right. And so 2 comes in the middle. X minus 2 comes in the middle. And similarly, you can write the last. Okay. So that's it. You know the polynomials. That's nothing to do here. Okay. So obviously that doesn't make you understand the formula. You know the formula. Okay. So it's okay for the time being where you do it. It's not a, okay. You do to find the answer, and then you can easily check that it indeed works. When you put the values, you check that it indeed works. That's fine. So yeah, this is easy. So maybe, so as I understand it, that this, to apply this formula, it seems like we did some other questions, but it seems like we will need more theory. So means it can be applied in problems, but something else also needs to be applied. So maybe we won't practice too much of this. Okay, but one question that comes to my mind, which I would just give now, is let's say that P is a, let's say, 10-degree polynomial. This may or may not need interpolation. Okay, that's, you have to judge that. 10-degree polynomial such that P of k is equal to one by k for k equal to 1, 2 till 10. Okay. And let's say that P of 0 is 2. That doesn't matter. P of 0 is 1. Right. Find P. Again, you may or may not use interpolation. That's completely up to you. You can use also, because I mean, theoretically speaking, I've given you 11 values, and this is a 10-degree polynomial. So, okay, I mean, so 10 degree, maybe I should just say, I mean, degree less than equal to 10. I've given you 11 values, and so you can apply interpolation. But you see, yeah, I didn't find any problems with interpolation. It's just a problem which came to my mind. Yeah, today I just end maybe 5 minutes early. Okay. Something is there to take care of. This is like the 6th class. Okay, Sundays is all classes. Okay, because weekdays I don't do any class. I just do my own classes and the studying. Sundays I have to teach and discuss. So 6th one. Yeah. In the, I mean, if you want to, you can just do by interpolation also. That'd be an option.
Sir, we have to tell P in terms of the Lagrange interpolation. Right?
In terms of
The interpolation, right?
interpolation, yeah. So you can tell me P, obviously it will be in terms of X, but you can, yeah, you can say it in any way. You can say it like if Px is X minus 1 times X minus 2 times X minus 3 plus or X to the power X to the, you can say it in any way, or factored form. Anything is fine. To give the whatever is the convenient representation, because moving from one representation to the other may be difficult. So whatever is a natural thing you get, you tell. Everybody forgot interpolation. Is it just let us just apply interpolation, right? What we get. So what will the compartment for 0 look like?
So would it be x minus 1 times x minus 2 till x minus 10 by 0 minus 1 into 0 minus 2 and till 0
Yes.
minus 10?
Yes, right. X minus 10 by the 0 minus 1, 0 minus 2, that will just become 10 factorial, right? Everybody knows factorial.
Yes.
So this is okay. Just following the interpolation formula. Nothing new. Right? So next term.
1 into x minus 2 into x minus 3 till x minus 10 by 1 minus 2, 1 minus 3 till 1 minus 10.
Right. And what will that be? 1 minus 2 times 1 minus 3. That will
9 factorial.
9 factorial, right? Plus 9 or minus 9? 9 factorial. Right.
I think minus 9 factorial.
Okay. 1 minus 2, 1 minus 3. Yeah, 1 minus 10. Right. Minus 9.
So wouldn't the first one also be minus 10 factorial?
Right. That may have been written wrong. 1 minute. So no, but then this is incorrect, right? There has to be x also here. Why is that not there? X minus 0. That has to be there, right? You did not say that.
Yes, sir.
I mean, yeah, Ishana said the second term, right? You didn't say that, right? Anyways, so yeah, it will be minus, and so whatever you can work it out. But is this? But this one is coming out to be 9 factorial. Okay, but minus 9 factorial, and then you're saying the first one is also minus 10. Let's see. You can just check. So it will be 0 minus 1, 0 minus 2. This is 0
The
minus
first
10.
one is positive only.
Positive.
First one is positive only, right? Right. And so what about, so well, here, this one, okay, so what maybe I will do is, and then you can try to see some pattern. So this one I will write as 10 factorial only, but I will write this 10. Okay, now next term is, so I'll just write it. Just check it, it's correct. So it's half, right? And so there is a 2, right? So it will be what? It will be 2 minus 0. Then you have 2 minus 1 and 2 minus 3 and so on. So this one will be more and more problematic, right? That pattern will not continue. 2 minus 1 is 1. 2 minus 3 is minus 1. And yeah, so it will be a little messy. But yeah, you can, point is you can write the answer. Not a, you'll get some numbers. There'll be some pattern in them, whether or not you want to write it. But it's a clumsy sort of. One can simplify that. But here there comes a point. So Lagrange interpolation is giving us an answer. But the point is there a better representation of the polynomial? So point is that using these bases, these products as my basis, the coefficients come out to be a little clumsy. Is there a better, well, there will be some pattern in that also. That will be there. If you work it out, you will see. But is there a better representation? So has anybody thought of doing this problem without Lagrange interpolation? Yeah. Because Lagrange interpolation doesn't care about the representation in that way. It only cares about the coefficients when the representation is done in this way, meaning using these chunks. They're not using powers of x, not in the factored form and so on. Right? It uses these as the chunks and it tries to calculate the, like you said last time we had some polynomial, and if you write it in powers of x, you want to use those things as your things to build up the polynomial. Or if you want to use powers of x minus 1 to build up the polynomial, or you want to use those products x minus 1 times x minus 2, x minus 1 times x minus 2 times x minus 3. You want to use those as your building blocks and see what coordinates or coefficients you're getting. That's up to you. And so Lagrange interpolation uses these as the building blocks, some sort of strange products with one thing missing sort of from the full product. Like each of the terms is like that, right? Like x is missing from the first, x minus 1 is missing from the second. So Lagrange interpolation gives you that kind of representation. But for this particular polynomial, is that the best? Meaning that what representation using what sort of building blocks will the polynomial be the simplest? Okay. So this is maybe what we can think of. So has anybody thought of doing this in a different way? So hint is to try to do it from the perspective of roots. Yeah. So if I'm telling that peak,
Sir, if the degree of the polynomial is a lower number, like 2 or 3, then you can use the sum of the products, sum of the roots and the product of the roots.
no, that is no, but okay. So what are the roots of what? Where is, so which polynomials roots are given to you? Is there any polynomial whose roots are given to us? That is really what I'm asking. Is there a polynomial whose roots are given to us? So this polynomial is roots of p are not given, right? But can you construct a polynomial whose roots are given to us? Well, we have done this trick earlier. You take kpk minus 1. This try to use this. That's all I can say. So what polynomial should I consider? What polynomial should I consider? I mean, suppose it was given that px is equal to 1, right? For let's say x for pk is equal to 1 for k in this, and for at 0 it is equal to 1. Now what would you consider, right? You would obviously consider the polynomial px minus 1, and you know that px minus 1 has these roots. What are the roots? 1, 2, 3 to 10. Is that right? Correct. Polynomial px minus 1 has 1 as a root because p of 1 minus 1 is 0. It has 2 as a root, and so you would say, okay, then px minus 1 has these roots, has these 10 roots. Obviously, there could be some coefficient here. Suddenly, you get the polynomial also. How do you find an? You have one more information. P of 0 is 1. So P of 0 is 1 means that P of 0 is 1, so this becomes 0. And okay, that's a unfortunate this thing. Maybe I'll change this. I'll change it because it's confusing. Just simply assume that it's 2 for now. 2 minus 1 is 1. And then what do you get? You put 0 in these just to find the an, that's all. 10 factorial, and so the an is 10 factorial. An is 1 by 10 factorial, 1 by 10 factorial, and that's it. You get px minus 1. And so px is just 1. Hold on. Is this something that is comfortable? Like we have done this kind of problem earlier, right? Or is it not? But do you understand this method so far? From the given information that k is equal to 1, right? We say, okay, pk minus 1 is 0 for k equal to 1, 2, and 3. So what is the underlying polynomial? Px minus 1, I put k. So I get the roots. Let's see. So if you understood this or not, let's do this simpler, not this problem. Let's do a slightly simpler problem. This problem. Just change this. So what if I tell you?
For k is equal to 0, k into pk minus 1 is not 0, right?
No, but k is not equal to 0 here. K is from 1 to 10. Right.
Okay.
That's why that's why I didn't give 0. But forget that problem for a minute and let's do this problem. Yeah, I can assume I'm changing it. Let's do this. It doesn't mean that p of x is x for all x. Okay? Don't say that will not necessarily be correct. That could happen. That we have to see. Once you do a bit practice, you would know when and when not. Any ideas? So with
So
the
in this case, both P of 0 and P of 2 will be 2, right?
that because P of 2 is given in the first code from the first part and P of 0 is 2.
Can we write P of k minus k is q into x minus 1 into x minus 2 till x minus 10?
P of k minus k is equal to
Some a or q into x minus 1 into x minus 2 till x minus 10.
how? This is k, this is x. This is certainly not true. This cannot be true. But then up to some notational problem. What is the notational problem? Well, this has to be x, right? K.
Yeah, it should be x.
If that is the polynomial whose roots are 1, 2, and 3, because when you put k, then right, and then you can find the so the meeting will end. So you find the q, and on the other side we'll discuss this, and then just join again. I hope you guys have the link. Pragadish, you don't have the link, so just I'll send you over mail. Okay.
No, I have the link saved.
Yeah,
It's
good.
okay.
Yeah, and then we'll discuss the other version of the question. Just join.